Welcome back. My name is Satyajeet Sahu and we will be solving the previous year questions of GATE. Okay. The original series name is Iit Kanpur Previous Year Question Series. Okay. But I will make it previous year questions of GATE. We'll complete the Iit Kanpur questions and also the questions asked in other years also. Okay. So this session was supposed to be held on Friday, but I was little sick. So I was not able to take class on Friday, so we are having today on Monday. Okay, so thank you very much. Welcome Raja, welcome Bijit, welcome Juhi. Okay, so let us start the session. Okay, and let me have a small introduction about myself. My name is Satyajeet Sahu. I have 10 plus years of experience in the field of GATE and ESE. Okay, and I have done my BTech in civil engineering from IIT Kharagpur. Also, I have done my master's in structural engineering from IIT Kharagpur. I have appeared for the GATE and I have got a very good rank of 127, through which I was selected into many of the PSUs, namely DMRC, IOCL, HPCL and RITES. I worked as design manager in Delhi Metro Rail Corporation, and then I have been teaching all across the nation. Okay, I have taught in more than 15 states and I teach all the civil engineering subjects. So let us start the session. Welcome Ritu, welcome Trader. Okay. So let us start the session without any further delay. But before starting, I will first explain some of the theory and then we'll be solving the questions. Okay. So it will not be only previous year. We will see some theory and then solve some questions. Okay. So first let us study something about what? Three things. Okay. So this is the IIT Kanpur series and we are solving today highway engineering. Okay, today we are solving what? Highway engineering. Okay, in highway engineering, I'll be covering this entire highway engineering in two parts. Okay, I'll be covering this in two parts. So today on Monday, that is 15th of August, I will be taking traffic engineering. Okay, so today I will be solving the questions of what? Traffic engineering. Okay, and tomorrow, that is on 16th of August. Okay, tomorrow it is on 16th of August. I will be solving questions on your geometric design. Okay, I will be solving question of geometric design. Okay, if you have any doubt, you can write in the comment section. If you have any doubt, write in the comment section. I will take that question tomorrow. Okay, geometric design and then highway engineer, pavement design. So tomorrow I will solve geometry design and pavement design. Today I will solve only traffic engineering. Okay. So let us start today's session with traffic engineering. So today's session will be on traffic. Okay. And then tomorrow on geometry design and pavement design. So welcome civil service examination, Aftab, Raja Khan, Lingaraj and others. Okay. So in traffic engineering, we have some basic terms. So we'll see those basic terms first. Okay. So we have a term known as what? Traffic density. We have a term known as what? Traffic density. Now traffic density is denoted by the symbol what? K. Denoted by symbol K. Okay. Now K is in what? K is in what? We'll see that. But what is K first of all? K is, suppose we have a road like this. Okay. And you are seeing a 1 kilometer stretch of this road. You are seeing what? 1 kilometer stretch of this road. Okay, so this length is suppose 1 kilometer. Okay, in this 1 kilometer there will be some number of vehicles. Okay, there will be some number of vehicles. Okay, suppose vehicles are scattered like this. The vehicles are scattered like this. There will be some number of vehicles. And that particular number of vehicles will be known as what? The traffic density. So what will be the unit of traffic density? Obviously it will be what? Vehicle per kilometer. So if I ask you what is traffic density, the answer will be the number of vehicles in a unit length, and unit length is how much? 1 kilometer length of the road. That is what? Traffic density. Okay, that is in what? Vehicle per kilometer. The next term is traffic volume or traffic flow. That is what? Traffic volume or traffic flow or flow. This flow is denoted by the symbol what? Small q. Okay, like we have a pipe. In pipe there is flow of water. Like that, on the road there is flow of vehicles, right? There is flow of vehicles. So if we have a road, like this, and you are seeing a certain point on that particular road, okay, certain point on that particular road, okay, suppose you sit here and then you are counting the number of vehicles crossing this particular point, okay. So if you count the number of vehicles crossing this point in 1 hour, that is known as what? Flow. You see, what is flow? If you remember your fluid mechanics or open channel flow, flow is what? For water it is what? Meter cube per second, right? Or I can say the volume of water per unit time, right? So here it is what? Instead of volume of water, it is what? Number of vehicles. Number of vehicles per unit time. And that unit time is how much? 1 hour. So I can say the number of vehicles crossing a particular point on the road, crossing a particular point on road in unit time, right? In unit time. And that unit time is how much? That unit time will take normally what? 1 hour. Okay, that is what? The traffic flow. It is noted what? Small q. Okay, so what will be the unit? Vehicle per hour. Simply what? Vehicle per hour. Okay, when we consider both ways. Okay, now, so this is your traffic volume and traffic flow. We saw the basic terminology. Next we will be going into what? The stream velocity. Suppose you see we have the road. Again, I will draw the road. You see these vehicles will have some different velocities, right? Right? So we take the average one. So if the average velocity, suppose I am taking that as v. So this I will call as what? The stream velocity. Okay, stream speed I can say, or I can just say the speed of vehicles on the road. Okay, so there is a beautiful relation between this stream speed, the traffic flow, and the traffic density. And that relationship is known as what? Q is equal to K into V. That relationship is what? Q is equal to K into V. You see, K is in vehicle per kilometer. Now velocity will be what? Speed will be what? It will be in kilometer per hour. So if you cancel these two, you can see that it is what? Vehicle per kilometer. So I can say what? This is nothing but flow, right? So this is the Ravindra Mehta will see that subsequently. I don't want to explain that concept now. Okay, so please have some patience to the lecture. You will understand. Okay. So Q is equal to K into V. So this relationship we established first of all. Okay, this relationship we established. Okay. Now we will see some terms. The first term is, which is asked a lot in the examination, is what? Is peak hour factor. Is what? Peak hour factor. So let us have some discussion on what? Peak hour factor. What is this peak hour factor? You see, suppose we are plotting the number of vehicles per hour, or can say flow per hour. Okay, so the flow will vary. If you are seeing through the day, suppose I am starting at 12 a.m. and if you are seeing the flow at different hours, the flow will be different, right? The flow will be different. You'll get a variation something like this, you see. Yes, something like this variation will get. Okay, this will be the variation of what? The flow. Or I can say flow, or I can say traffic volume. Or I can say what? Traffic volume. Flow or traffic volume. Okay. See, in the morning there will be some peak around 7-8 a.m. right? In the morning when the office is opening, that time there will be some peak, right? And then I can say in the evening hours also there will be one peak. Okay. And most probably what happens? In the evening only we get the peak volume. We get what? The peak volume. So this is what? This I can say is the peak hour volume. This I can say what? The peak hour volume. Okay. Now this peak hour volume is a hourly volume, right? It will be what? Vehicle per hour. Suppose that peak volume is, suppose I am giving the name as QP. Peak hourly volume. I am giving a name what? QP. Peak hour volume. Suppose that hour is 6 to 7. For some places it might be 6:30 to 7:30. For some places it might be 5 to 6. For some places it might be 7 to 8. It varies from place to place, right? It varies from place to place, okay? But there is a peak hour volume, suppose, okay? So I am telling that there is a peak hour volume, okay? Peak hour volume, and that peak hour volume is what? QP. And this is in 1 hour, right? These many vehicles in 1 hour, I can say, in 1 hour. And that 1 hour can be anything, depends on the place, okay? Now this peak hour volume, suppose I am telling this is 4,000. Suppose I am telling this is 4,000. It's an example, it's not a standard value. An example that it is 4,000 vehicles. It is 4,000 vehicles. Now, all the 4,000 vehicles will not come in 5 minutes, right? It will not come in 5 minutes. Suppose that 1 hour is, suppose it is 6 p.m. to 7 p.m. Suppose it is 6 p.m. to 7 p.m. Okay? So it will not come in 5 minutes or 10 minutes. Okay? There will be a distribution. So what I will do, I will find out 15 minutes traffic. Means what? I will first find out that what is the number of vehicles from 6 to 6:15 p.m. Then 6:15 to 6:30 p.m. right? Then 6:30 to 6:45, and then 6:45 to 7 p.m. Okay? So I'll find out the 15 minutes distributions. I'll find out what? The 15 minutes distributions. Suppose I am getting here, suppose I am getting 900, then suppose I am getting 1200, suppose then I am getting 1100, and then I am getting 800. You see the total will be how much? If you add them, they will be 4,000, right? Getting 4,000, right? Total is 4,000, but they are not evenly distributed. You can see they are not evenly distributed. Okay? So to understand the distribution, we introduce a term known as what? Peak hour factor. We introduce a term at what? Peak hour factor. Now what is this peak hour factor? This peak hour factor is equal to the peak hourly volume divided by 4 into, why this 4 I will tell you, don't worry, 4 into maximum 15 minutes traffic. Maximum 15 minutes traffic. So for this particular data, if I ask you find out the peak hour factor, what will be the answer? Tell me. For this particular data, you see this data which I have written here, if I ask you what is the peak hour factor, what will be your answer? Tell me. What will be your answer? This is the peak hour volume, so this will be how much? 4,000. Yes. And what is the maximum 15 minutes? It is 1200, right? So this is your 1200. So what is the answer? Tell me for this data. For this data, what is the peak hour factor? Can you tell me? Please find out and tell me. Attav is telling 0.83. Yes, Itulamba is telling 0.83. So here the peak hour factor we are getting is how much? We are getting is 0.83. Okay, it is how much? 0.83. But what is the use of this? What is the use of this? Why we are finding at all? Yes, why we are finding at all? Let us see. See the data, sorry. Here we got 0.83. Here we got data is how much? 0.83. But data can be different also. For example, I am telling suppose the 15 minutes data are suppose it is 400, okay, then 1600, okay, then 1200, and suppose 800. So data is, suppose this is the data, the 15 minutes data, suppose this is the data, okay. So initial data was how much? Initial data was 900, and then 1200, and then 1100, and then 800. This was the original data. And for this we got the peak hour factor how much? We got this as 0.83. So can you tell me what is the peak hour factor for this data? What is the peak hour factor for this data? Can you tell me? What is the peak hour factor for this data? What is the peak hour factor for this data? Please find out. See, the total one is same, 4,000 only. Total one is 4,000 only. You see the maximum 15 minutes is this one now. Earlier it was this one. Now it is 1600, right? So what is the answer getting? Yes, we are getting 0.625. Getting 0.625, right? Now suppose data is not this, suppose data is this, you see. Suppose data is 950, 1050, 900 and 1100. Now tell me what will be the peak hour factor? What is the peak hour factor? Tell me. You understand a beautiful concept. Here see the maximum one is this one and total is 4000 only. How much you are getting peak hour factor? You are getting 0.909. You are getting 0.909. Okay, very good. Now tell me what is the peak hour factor for this? What is the peak hour factor for this distribution of traffic? What is the peak hour factor for this distribution? Please tell me what is the peak hour factor for this distribution? See 1000, 1000, 1000, 1000. The maximum one is 1000 only, right? So how much is the peak hour factor? The peak hour factor will get 1. The peak hour factor will get how much? 1 in this case. So what we understood from the peak hour factor is that you see it is the most uniform traffic, right? You see it is the most uniform traffic. So if the traffic is fully uniform, then the peak hour factor will be 1. Yes. And as the uniformity varies, the traffic is becoming more non-uniform, then what will happen? Then the peak hour factor will reduce. You're able to understand? You see, if you see the uniformity, you can see that this is most uniform, right? Then little less uniform, then little less uniform. You see, this is very non-uniform. 400, 1600, 1200, 800, right? So I can say that as the uniformity increases, the uniformity of traffic increases, then peak hour factor increases and approaches what? 1, right? And approaches what? 1, right? Approaches 1. Yes, so this question they might ask you, yes. And as the uniformity decreases, yes, I can say that peak hour factor decreases. Okay. So peak hour factor indicates the uniformity of the traffic. Okay. Now some more knowledge about this. You can easily answer the questions. Now see, when I say peak hour factor, I am finding for 15 minutes interval, right? So I am writing this as peak hour factor 15, and that is equal to the peak hour volume divided by what? 4 into maximum 15 minutes traffic. You see, why we are writing this 4? Because you see, because we have 60 minutes, and in 60 minutes I am dividing into what? 15 minutes interval. So the peak hour will have 60 minutes, right? 1 hour 60 minutes, and I am dividing into what? 15 minutes interval. So this is what? 60 by 15 minutes, what? 4. Or I can say I have 4 intervals. Therefore we are having this what? 4 number. Understood? Now if I go for the maximum and minimum value of this particular thing, the maximum value will be what? The maximum value will be 1, right? The maximum value will be what? 1. The maximum value of peak hour factor is how much? 1, right? Yes, when it is complete uniform, right? When it is fully uniform, then I can say it is 1. Now what is the minimum value? The minimum value will be what? Theoretically it is 0.25, or I can say 1 by 4. And when that will occur? When this peak hour volume becomes equal to what? The maximum 15 minutes traffic. The maximum 15 minutes traffic. Suppose I am telling that for the first 15 minutes there is no traffic, for the next 15 minutes there is no traffic, and then all the 4000 vehicles came in that third interval, and then again no traffic. Now this is a theoretical thing. It's not possible that you'll get 0, 0 and then 4000 and 0. But theoretically it is possible. So I can say, theoretically I can say that when this occurs, then the minimum value will be how much? 1 by 4. Understood? The minimum value and the maximum value of peak hour factor. How we find out peak hour factor? What peak hour factor indicates, you understood, right? And then the maximum and minimum value. Now this maximum and minimum value we understood for what? We understood for your 15 minutes interval. I can divide this into what? 10-minute interval also, right? I could have divided into 6:10 to 6 to 6:10. Yes, I could have divided into 6 to 6:10 and then 6:10 to 6:20, right? And then 6:20 to 6:30, right? And then 6:30 to 6:40, right? And then 6:40 to 6:50, and then 6:50 to 7. I could have done this also. Now, if this is the case, I am dividing into 10 minutes interval, then I will find out the peak hour factor, and that will be what? For 10 minutes. So, it will be what? Peak hour factor 10. And here, numerator it will be what? QP divided by the maximum 10 minutes traffic, right? Maximum 10 minutes traffic. You see, there will be 1, 2, 3, 4, 5, 6 traffics, right? Choose the maximum one. And here I will write down how much. What will be the number here? Tell me. What will the number here? Tell me. Please tell me what will be the number here. What will be the number here? Tell me. What will be the number here? Tell me. If you are finding 10-minute peak hour factor, if you are finding 10-minute peak hour factor, what will be the number here? It will be 6. Why? Very easy. Because I am dividing into 6 intervals. Or I can say 60 by 10. 6. So if this is the case, if you are finding 10 minutes peak hour factor, then what will be the maximum value? The maximum value will be still 1 only. When it is complete uniform, maximum value will be still 1. Doesn't vary if you are varying the intervals. But the minimum value will change, right? The minimum value will become how much? 1 by 6. The minimum value will become 1 by 6 when this becomes equal to this. Very simple. Okay. So for when they're asking you peak hour factor, maximum minimum, you have to ask that is it for 10 minutes interval or 15 minutes interval. If 15 minute interval, then the minimum value is 0.25. But if it is 10 minute interval, it is 1 by 6, it will be close to how much? 0.167, right? Right? But the maximum value will be still 1. The maximum value will be still 1. And if I write down, suppose peak hour factor 5, means what? 5-minute peak hour factor. Can you tell me what will be the maximum and minimum values for this? Tell me. Let me ask you a question. 5-minute peak hour factor, tell me the maximum value and also tell me the minimum value. Come on, tell me. 5-minute peak hour factor, the maximum and minimum values, please tell me. One and 0.83, why 0.083? Yes. See, maximum will still remain 1, but the minimum one will become what? 1 by 12. So that is how much? 0.083. 0.083. How? You see, this 5 minutes will be how much? It will be the peak hourly volume divided by the maximum 5-minute interval traffic, and then 5 minutes means what? There will be 12 intervals, right? In a 60-minute hour, obviously hour is 60 minutes only. So divide by 5. So how much? It is 12, right? It will be 12. So the minimum value will be 1 by 12. Understood? So very simple thing which they ask you. But you understood everything about peak hour factor? Let us solve some questions, some previous year questions of your GATE. So please solve this question. Please solve this question now. So initially I will be giving you some theory behind the things, and then we'll be solving some previous year questions. Because if I just solve without giving the background theory, then that is of no use, right? What is the answer to this? Round to two decimal places. Round to two decimal places. Please mention the answer. I don't have the calculator. Oh, here it is. Okay. 0.52. Very good. Yes. It is written that the maximum number of vehicles observed in a 5-minute period during the peak hour is 160. So this I can say is what? The Q5 max, right? Q5 max. And this is how much? 160. And the total flow in the peak hour is 1000 vehicles. So the peak hour volume is 1000, right? They're asking the 5 minutes peak hour factor. Yes. That is very simple. It will be the peak hour volume divided by the maximum 5-minute one. And then you'll multiply how much? 12. This is how much? 1000. So you see, you don't have to, my calculator is malfunctioning. Desi technique. No, it's still malfunctioning. So I'll depend on the answer given by you. It is given how much? 0.52. Understood? So you see, so simple, and it's so simple to remember the formula, right? So they ask you 5 minutes, 10 minutes, 15 minutes, 20 minutes. Then also you can answer questions on peak hour factor. Now answer this very easy question. Please answer this very easy question. The theoretical possible range of peak hour factor. Please answer this. Very simple question. Arsenal is laughing. It's not working. C. Arsenal is saying C. Others? Sleeping? Wake up. Okay, the answer is C. Just now we saw. So I can say that peak hour factor 15 minutes will have the range of 0.25 to 1. Similarly, peak hour factor 10 will have a range of 0.167 to 1. And peak hour factor 5 minutes will have range from 0.083 to 1. What will be the range of peak hour factor 20? What will be the range of peak hour factor 20? Tell me. What will be the range of peak hour factor 20? Or suppose peak hour factor 30. If they ask you, chance is very less because we don't go for 20 minutes and 30 minutes intervals. But suppose they ask you, suppose they go crazy and they ask you a very theoretical question. Then what is the answer for this? Suppose 20 minutes interval and 30 minutes interval. Yes. For 20 minutes, then I can say it will be peak hour volume. Then what? Divided by the 20 minutes max, and then what? 60 by 20. So 3. So when this becomes equal to this, it will be 1 by 3. So 0.33. Okay. And then 1. Right. And suppose it is what? It is 30 minutes. Then it will be 2 intervals. So 1 by 2. So 0.5 to 1. Yes. So see that the maximum value of the peak hour factor doesn't change. The maximum value is not changing. The minimum value is changing. Now any question they ask on peak hour factor, you can easily answer, right? Now see, this is a very easy question. I can ask in 2014. The minimum value of 15 minutes peak hour factor. The answer is 0.25, right? But I explained you lot more than what previous year they have asked, right? So thank you very much. Let us go to the next thing. Let us go to the next thing. The next thing we'll see is headway. We'll discuss something on what? Headway. And what we get from headways. Okay. Now the headways, we have two headways. One is the space headway. One is the space headway. Okay. The other one is time headway. The other one is what? Time headway. Now what's the difference between them? Very simple. See, suppose we have a road. A road is there, okay. And then there are two consecutive vehicles. These are what? Two consecutive vehicles, right? Two consecutive vehicles. So the spacing between these two vehicles will be known as what? The space headway. This spacing will be known as what? The space headway. This spacing known as what? Space headway. You see, this space headway, you see very interesting thing. It is either from the back to back or front to front. Okay. You see, either this distance or I can say this distance. Either I see from front to front or from back to back. Okay, so this is space headway. This is space headway. Understood what is space headway? It's the distance between what? Two consecutive vehicles on the road. Two consecutive vehicles on the road. Very simple, right? Now what we get from the space headway? Let us see what we get from the space headway. Okay. Now tell me, suppose this space headway is in meter. It is in meter. Now tell me, in S meter, how many vehicles are there? Tell me. In S meter, how many vehicles are there? Tell me. In S meter, how many vehicles are there? Number of vehicles, tell me. In S meter, how many vehicles are there? Tell me. In S meter on the road, how many vehicles are there? How many vehicles are there in S meter? There is one vehicle only. You see, if I just remove this one, you see this. Here only one vehicle is there, right? Because you are seeing from the back to back. You are seeing from back to back, you are seeing only one vehicle is there, right? So only one vehicle is there. So if I apply unitary method, I can say in 1 meter, there will be what? 1 by S vehicles, right? If in S meter 1 vehicle is there, then 1 meter, 1 by S. In 1000 meter, how many vehicles will be there? There will be 1000 by S vehicles. There will be 1000 by S vehicles, right? Now you see this 1000 meter is what? 1 kilometer. So I am saying in 1 kilometer road, this many vehicles are there. This is what? Traffic density, na? This traffic density, na? Definition of traffic density was what? Initially I told the traffic density is what? That 1000 by S. Now we got that, right? So I can say I get the traffic density, that is how much? 1000 by S. And this will be one way. We'll be seeing what? One way traffic only. The question which was asked earlier, answered, okay? Understood? So from this you calculate what? From your space headway, we get the traffic density. And this will be in what? Vehicle per kilometer. Okay? This will be in vehicle per kilometer. You see this S is in meter. S will be in meter, but we'll get the answer in vehicle per kilometer. Why? Because we are finding for 1000 meter. So 1000 meter is 1 kilometer. Understood? Okay. Now this is your space headway. This is what? This is your space headway. Now what is your time headway? It will be very similar to space headway. It is similar to space headway. How it is similar to space headway? Space headway was the distance between consecutive vehicles, right? What is time headway? Suppose you have the road and there is a particular point. Now what you do? You sit here. Then what happened? Suppose one vehicle passed. When the first vehicle passed, okay, you started a stopwatch. So it passed, then you waited. Then the next vehicle, the next consecutive vehicle passed, okay? And then you stop the vehicle. That means what? What is that particular time you noted? That time is the time difference between the arrival of or departure of two consecutive vehicles, right? Okay. If you are seeing that when they are arriving or departing, that depends, right? You see, if you are seeing here, when they are just arriving, one, started the stopwatch. Then when the second arrived, you stopped the stopwatch. This is what I can say difference between the arrival. Difference between the arrival of two consecutive vehicles. Or suppose when the first vehicle departed, you started stopwatch. Then when the second vehicle departed, you stopped the stopwatch. So I can say the time difference between the arrival or departure of two consecutive vehicles is known as what? Your time headway. So time headway is what I can say? Time headway. And it's a time, because starting and stopping a stopwatch time, so I can say it is mostly in seconds. Time headway in seconds is time difference between, it is the time difference between the arrival and or either you say arrival, you compare two arrivals, or I can say you compare two departures, right? Or departure of two consecutive vehicles. departure of two consecutive vehicles. So two consecutive vehicles you will take and then compare this. And that is what? That is your time headway. Now, in this, suppose I am telling this is HT, suppose time headway, HT seconds. So I can say in HT seconds, I can say in HT, time headway seconds, can I say only one vehicle passed? Okay, unknown heaven, nice to see you, thank you very much. Okay, so in HT seconds, actually how many vehicles passed or crossed this point? If you are comparing the departure, so departure means first this vehicle is here, already it has crossed this point, right? Departing means it has already crossed the point. So this vehicle I cannot consider that it has crossed the point, right? So once it passes, then the second vehicle will be coming, right? It will come like this, come like this, come like this. When it is reached here, when it's departing from this particular point, then I will stop. That means in that particular time interval, that time headway, only one vehicle crossed this, na? Only this one vehicle crossed this, na? Only one vehicle. That was this 2-1, right? This 2-1 crossed this point, because when you're seeing the departure, yes, then one vehicle means first vehicle has already crossed. Understood? Understood? So I can say in HT seconds, one vehicle passed or crossed, right? One vehicle passed or crossed. So now in 1 second, 1 by HT vehicles will cross or pass. In 3600 seconds, then how many vehicles will cross? 3600 by HT vehicles will cross this particular point. And this 3600 seconds is what? It is 1 hour, right? So in 1 hour, this many vehicles passed or crossed is nothing but the traffic flow, na? Traffic flow is the number of vehicles crossing a particular point in 1 hour, right? So I can say this time headway gives me what? This time headway gives me the traffic flow, where this time headway will be in seconds, but I will get the flow in what? Vehicle per hours. So we understood two important terms and where we use it. Time headway, it's a difference between the arrival or departure of two consecutive vehicles on the road. It will be in seconds, and from that I will get a traffic flow clue, right? And then we saw the space headway. It is the distance between two consecutive vehicles. That will be in meter, okay? And then from that I will get the traffic density. Understood? Very good. Let us solve some easy questions asked in GATE. Solve this question and tell me what is the answer. Very easy question. I'll drink some water by that time. Easy question, very easy question. $1200, very easy question. Yeah. You see, time headway is 3 seconds. Okay. Time headway is 3 seconds. That ideally they have asked the flow. Okay, flow. So Q is equal to, I can say 3600 divided by what? This is 3, that is how much? 1200 vehicles per hour. So you see, very simple questions are asked in the GATE if you have covered the basics. Now solve this question, another easy question. The average spacing between the vehicles is this. And again a very simple question. Sorry. Very easy question, very easy question. As I told that the space headway gives what? It gives the traffic density. So very easy questions, okay. So it is 20 vehicle per kilometer. Now these things are also used when we solve the questions, okay. So next thing we'll see is something known as traffic flow models, okay. traffic flow models. Okay. Now we know this relationship. Which relationship we know? We know the relationship of what? Q is equal to K into V. Okay. But we don't know the relationship between what? K and V. Right? We don't know the relationship between what? K and V. Now this relationship between K and V can be anything. Right? I can say that V can be, I can say that your V can be a linear. It can be a linear function of K. Right? It can be a linear function of K. It can be a parabolic function of K. Right? Means K square. Right? Now you see this linear or parabolic or cubic, they are all algebraic. It can be a trigonometric function. It can be an exponential function, right? It can be anything, any kind of function, right? Right? But we'll study first what? And the most important one which is asked in the examination, that is your linear function. That V is a linear function of K. So when I say linear function of K, what is the linear equation? Y is equal to mx plus c. This is the linear equation, linear relationship. Okay. So here the linear relationship is between what? Y and x. So when I am saying the relationship between V and K, so in place of Y I will be putting V, and in place of your x I will be putting K. Okay, I am putting K. Okay. Now here I will use two constants. Okay. See, this m is the slope na, and c is a constant. But slope is also a constant. Like in linear function, it's a constant, right? Yes. And here I will use this. I will use as VSF or VF, VSF or VF, okay, or UF in place of what? This C. This C is what? It is the intercept, right? In the linear equation, it's the intercept. Yes. And in slope, I will use minus VSF by Kj. What is this? What are these two constants? They are basically two constants, right? You can see this is basically two constants. If you compare, I can say that this VSF is the intercept and this minus VSF by Kj is what? It is the slope, I can say. Now, what are these terms? Okay. This VSF or VF or UF is the free mean speed. It is given a name what? Free mean speed. What is this? We'll understand from the graph, don't worry. And what is this Kj? Kj is the jam density. When there is jam on road, then this is what? This is the jam density, right? Yes. And how to find out jam density? Very easy. When there is jam density, you can have the average spacing between the vehicles, right? You can have the average spacing between the vehicles. So, from this formula, you can find out what? The jam density. Because just before some time, we saw that the density is what? 1000 by space headway. Or space headway is nothing but what? The spacing between vehicles, right? So this is your jam density, means when there is jam. Let us analyze this equation a little more. Okay. So I told that V is equal to or minus VSF by Kj, and then again VSF, and then I am putting this K. So this is a linear relationship between what? V and K. Now I can simplify this equation and I can take VSF common. If I take VSF common, what I am getting? 1 minus K by Kj. So this is the equation I am getting. Okay, this is the equation I am getting. Now, very interestingly, if I plot between what? Between your V and K. Between V and K I will plot. Then I should get a linear curve. Yes, I should get a linear curve. Now, here on this axis, V is 0 na. If you put V0 in this equation, if you put V0, then K equal to Kj I am getting na. You see, if V is equal to 0, that means what? 1 minus K by Kj is also 0. Or I can say 1 is equal to K by Kj, or I can say K is equal to Kj. And that is obvious na. When there is jam, means K is equal to Kj means what? Density is equal to jam density. Then the speed of the vehicles, or I can say the stream velocity will be 0, na? Yes, yes, I can say. So this will be 1 point here. And what will be the coordinates? The coordinates will be, the k coordinate is kj and velocity is what? 0. Understood this point? Yes. When the density is equal to jam density, velocity will be 0. Right? Then we'll see another point here. Here the density is 0, right? The density is 0 because you see this is the y-axis, this is the x-axis. And x-axis I am taking as k and y-axis I am taking at v. So on the y-axis, x is 0, or I can say k is 0. So if k is 0 here, in this equation put k 0. In this equation if you put k 0, then I can say v will be equal to VSF, na? I'll get v is equal to VSF. So I can say that VSF, or the free mean speed, is that velocity such that the traffic density is 0, right? Now this will be a straight line. You see, this is a straight line, right? Because it's a linear relationship. Understood this curve? Now you might have heard this curve many times, but still I wanted to explain you again. Those who are studying this for first time, very good. You're not studying for the first time, then I can say it will act as a revision. Okay, so linear relationship. Very good. Now they have asked a very basic question on this. So let us first answer that question and then you can come back to the theory. You see, this question was asked in GATE 2015. Okay, so this is the IIT Kanpur one. Okay, we are solving many questions. So this is one of the IIT Kanpur questions. Now tell me, what is the answer to this? What is the answer to this? D, very good. Okay, very good. So some students have answered it correctly, others are thinking, so I will answer. You see, I told this is the free mean speed, or I can say here it is written UF, or I can say this as what? VSF, right? I can say as VSF. Okay, what is written? That it is the speed. Let us see, it is what? Cannot be used. Cannot be used means what? Which is the wrong statement, right? You see, UF is the speed when flow is negligible. Is it? Let us see. See, when the speed is equal to VSF, you see, when the flow is equal to VSF, means the speed is equal to VSF, yes, then the K is 0, na? Yes, in this equation, I will write down the equation here. Here only I will write down the equation. You see, this equation is V is equal to VSF 1 minus K by Kj. So when V is equal to your VSF, then what I can say? This K is equal to 0 you are getting, na? Are ha ya na? Nobody is telling anything. Ha. Please tell ha. You can write down ha or na or whatever. Okay. Nobody is telling. Ha. Yes. Very good. So K is 0. Now what is your flow? Flow is equal to K into V, na? Flow is equal to K into V, na? So when your K is 0, that means Q is also 0. So that is what is written, you see. When the speed is UF, or I told that is VSF is also known as UF, okay, or free mean speed, your flow is also negligible. Negligible means what? 0. Yes, and density is also 0. So these first two statements are correct only. These first two statements are correct only. It is written cannot be used. So these are correct statements. Cannot be used means what? Find out the wrong statements indirectly, right? Cannot be used means find out the wrong statements. So first two statements are correct. Now obviously all these things will be affected by what? The geometry and surface condition. So this is also correct. Now, why the last statement is not correct, that we will understand now. That we will understand now. See. So, what was relationship analysis? That VSF is equal to, B is equal to, VSF, okay, then 1 minus K by Kj. Now, what is your flow? Flow is equal to K into V. Flow is equal to K into V. Now, in place of this V, I can write down this equation, and this will be K into VSF, and then 1 minus K by Kj. Yes, if I take this K inside, what will happen? Q is equal to VSF, then K minus K square by Kj. So you see here what happened. This Q now became a function of what? The K. Because you see VSF is constant, Kj is constant. So Q became a function of K. Q became a function of K. Okay? Q become a function of K. Now, if I want to maximize Q, what I will do? I will differentiate Q with respect to K and make that as 0. Okay? So, let me differentiate it. But I will not differentiate this VSF because that is a constant, right? So, I can take it outside. I will differentiate this only. If I differentiate with respect to K, dQ by dK, so it will be what? K differentiation will be 1 only, and then K square will be 2K by Kj, and this is equal to 0 for maximizing, or I can say K will become how much? Kj by 2. Now many people know this equation. Somebody might be thinking, sir, this is very easy thing. I know. Okay, if you know, then don't attend the class, no problem. Okay, for people who want to revise, I am revising. Yes, okay. So this we got. Now, this is the value of K for Q is equal to Q max. If I want to find out the value of V, what I will do? In this V equation, I will just put it, right? In this V equation, I will just put it. So it will become what? VSF 1 minus Kj by 2 divided by Kj. This will become half, right? Kj by 2 divided by Kj, half. 1 minus half is half. It becomes what? VSF by 2. So I can simply say by erasing all this thing that for a linear model, V is equal to VSF 1 minus K by Kj. Yes. And I told that Q is equal to KB will be applicable for all type of relationships, and I will get a maximum Q for this model when K is equal to Kj by 2 and V is equal to VSF by 2. And you see the last statement there. It is written that VUF or VSF is the speed at which flow is maximum and density is optimum. That is false, na? That is false. This is false. Why? Because the flow is maximum when? The flow is maximum at VSF by 2, or I can say UF by 2. It is not maximum at UF. Understood? So see, we are able to solve this question. Now, let us solve another question. Please solve this question. I am giving you some time. Please solve this question. Please solve this question. I will solve. I got the answer. Others? Very easy question actually. It's a very easy question. Hey, why are you taking so much time? Linearly related means linear relationship. Yes. The free spin speed is given, the jam density is given. the traffic flow corresponding to speed of 40 km per hour. Why you are taking so much of time? 2000. See, VSF is given 80, right? And your KJ is given 100, right? VSF is given 80 and KJ is given your 100. They are telling that the speed is now 40. Yes, what is given? The speed is 40. When the speed is 40, indirectly they are telling this is what? VSF by 2, right? So VSF by 2, when the speed is VSF by 2, then Q is equal to Q max. And what is Q max? Q max will be the K and V at Q max. So this is what? KJ by 2, and this is what? VSF by 2. So how much I am getting this? This will be simply 80 into 100 divided by 4, giving me how much? 2000 vehicle per hour. Now suppose you have, somehow you forget this formula. Suppose somehow you forget this formula. Then what? Then also easy. How? You see, this is your V given. So V is how much? VSF 1 minus K by KJ. So this is 40 is equal to VSF is 80, then 1 minus K by KJ is 100. So from here I can say, I'll bring, this will be 2, right? So half is equal to 1 minus K by 100, or I can say K by 100 is equal to half, or I can say K is equal to 50, yes? So for this speed, V is equal to this, I got the K, and what is the Q? Q is simply K into V, that is what? 40 into 50, that is how much? 2000. So you need not always check that. See, coincidentally it came that it is VSF by 2. Yes, but every time it might not be VSF by 2, right? Then you have to solve by this method. Or suppose this same question I ask you, find flow at speed of 30 km per hour. Let us see. Find out flow at speed of 30 km per hour. Please find out. Please find out this answer. So see, this 30 is not VSF by 2, right? This is not VSF by 2. This is not VSF by 2. So in this case, you cannot just apply, Qmax. Then you have to go by the proper method, proper thing, right? It is not VSF by 2. Please solve and tell me. 1875. Very good. Somebody has found. Aptap has found. Very good. Same method. This is your V. Use the equation. V is equal to VSF 1 minus K by KJ. So you see V is 30. VSF is how much? VSF is your 80. And this is 1 minus K by 100. Yes. So this will be 3 by 8 is equal to 1 minus K by 100. Or I can say K by 100 will be equal to, you'll get 5 by 8, I think. Right? Yes. And this you will get 12.5 into 5. K you will get how much? K how much you are getting? How much you are getting K? 62.5, right? You are getting K as 62.5. Yes. And then Q will be equal to simply KV. That is equal to how much? 30 into 62.5. This you are getting 625 into 3. That is 1875 vehicle per hour. You see, this speed was not VSF, and therefore you see this flow which you got, that was less than the maximum flow. The maximum flow you got is 2000, getting less than that. So always they might not ask you the maximum flow, right? See, in this question which was asked in the GATE, it was coincident that they asked the flow for the maximum flow, but they always might not ask what? The maximum flow. So then you have to go for the original equations like this. Understood? Very good. Let us solve another question. Solve this very easy question. Okay. So it is given you that is same as what? V is equal to 70 minus 0.7 K. What is the capacity of the road? Capacity means what? The maximum flow. Capacity is nothing but what? The maximum flow. Please find out this. Very straightforward question. See, this question can be solved in two ways. Many students know how to solve this question, so it's not a new question. But we are having practice session, obviously, so we will practice the same questions with little variations. Okay, somebody will say, already I know everything, sir. Why you are solving the same thing? Okay, please go to Antarctica and find out the characteristics of the snow in Antarctica. Do some research. What I can do, if we are studying traffic and you have solved everything, then you will get the same questions only. So I can't do anything. So what's the answer for this? What's the maximum flow? K is equal to 50, Q is equal to 1750. Very good. I don't know the answer. Calculator worked. Yeah, 1750 is the answer. Yes. So you can solve this question in two ways. Suppose you don't know the formula and basic things, you don't know anything, suppose. But you know that Q is equal to KV, right? You know this one, right? So what you do, K, in place of V you can write on what? 70 minus 0.7 K. That is how much? 70K minus 0.7 K square. Right? Q is equal to this you got. Now if you want Q max, then what you do? You differentiate it with respect to what? K. That is how much? 70 minus 1.4K, and this is equal to 0 for making it maximize. So I can say from here K is equal to how much? 70 by 1.4 giving me how much? 50. So at K is equal to 50, I am getting this maximum value, right? Getting Q is equal to Q max. So very easy. In this equation put what? K is equal to 50. So it is 70 into 50. Yes, that is how much? 3500 minus 0.7 into 50 square. That is how much? 50 square will be how much? 2500. So it will be how much? 7.7 into 2500. 1750. So we are getting what? 1750. So this is one way to find out. Understood? If you don't know the formula and all, you can directly use simple mathematics, right? If you don't know formula, then you know simple mathematics, na? Why to always remember formula? If you not remember formula, by using simple mathematics also you can solve these questions very easy. But suppose you want to use the formula also, then this equation can be written as what? V is equal to, I can take 70 common. Then what will be remaining? 1 minus 0.7 by 70, right? 0.7 K by 70. This will become what? 100, na? So I can write down this as what? Minus K by your 100. If you see this equation, you see this equation is similar to the linear equation, which is what? This is VSF and this is what? The KJ. So game over. The maximum flow will be how much? The maximum flow will be equal to 70 into 100 divided by 4. That is how much? 1750. Or suppose you are not able to, identify and form these equations. Then also very easy. We know that at K is equal to 0, V is equal to VSF, na? So in this equation put K is equal to 0. So what is your V? You are getting 70, na? Yes? Yes. So VSF is 70. And we know that at V is equal to 0, K is equal to Kj. Right? So here if you put V is equal to 0, then K how much you are getting? You are getting 100. You see in this equation if you put V0, so 0 is equal to 70 minus 0.7 K. So K is how much? 70 by 0.7, that is how much? 100, na? So that is what? Kj. Yes. So you got VSF Kj, VSF into Kj by 4. How? You see this graph. Initially I told this graph, na? You see? You see? At V is equal to VSF, K is 0. Yes. and at k is equal to kj, b is 0. Understood? So like this also you can solve the same question in 3 ways, right? You can solve the same question in 3 ways. Okay. Let us go to something known as what? Your Webster's signal design. Okay, Webster's signal design. Okay, Webster's signal design. Now, why we design a particular section or intersection? Okay, why we design a particular intersection? Design means what? We have signals because there are conflict points. There are what? Conflict points. Suppose we have a road like this. Suppose we have a road like this. Suppose we have a road like this. This is a 2-lane road. Okay, there are 2 roads and both are 2-lane. So you see, some vehicles will go straight like this, and like this. Like they will go like this, right? Some vehicles will go like this. Yes. Yes, and some vehicles will go like this. So when they are trying to pass, there is conflict. What is the meaning of conflict? The meaning of conflict is that at this point I can say, there will be 2 vehicles who will be telling that I want to go first. This is what conflict points. Okay. Or I can say there is a chance of what? Accident there. I can say in that way. Is conflict points. You can see that 4 conflict points are formed. This is for straight through traffic. You can see these vehicles are traveling straight, right? So now some vehicles will turn left, right and all. Suppose they are turning left. Suppose this vehicle is turning left, so there is a conflict here, right? And suppose this vehicle is turning left, then there is a conflict here, I can say, right? Where they can have a accident, or as Arsenal told, takkar, and an Aptitude told collides. Very good. Okay. Then there will be a conflict point like this, right? Then there will be a conflict point like this. And now suppose I can say there will be another conflict point where left turning traffic, one left, this left, another left here, right? You see, so more conflict points are formed. This is for left turning. If there is we allowing right turn, okay, there will be more conflict points. You can see when you allow right turn, then so many conflict, right? One right turn, right? I can say another right turn like this, right? Yes, I can say another right turn like this, right? And I can say another right turn like this, right? No need of any animation. Okay, so here you see that more conflict points are generated. Okay, you see there is a conflict point here. I will draw this in red, this in green. You can see one of the conflict point is here, then here, then here, then here. Okay, so 4 more are generated to do this right turn, right? And you can see that here so many conflict points are there. Okay, you can see so many conflict points are there. All these red ones, okay, all these red ones are known as what? The major conflict points. You can see here so many conflict points are there, and these are what? The major ones which are happening, major conflict points which are happening what? You see at that particular intersection, and it will have what? Very heavy impact. If the accident happens, there will be heavy impact. How many are there? Can you count? How many are there major conflict points? Can you count and tell me? Sorry. Can you count and tell me major conflict points? How many are there? Some people know the answer, but still I want you to count. Some people know the answer, but still I will tell you to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I can say these are what? The red ones are what? The major conflict points. And if I tell you to count the other ones, the green ones, they're known as what? The minor conflict points. They are known as the minor conflict points because you see the impact will be less. They will be having less impact on the vehicles. And there are how many? 8. There are how many? 8. You see 1, 2, 3, 4, 5, 6, 7, 8. So I can say when we have two roads, you see we have two roads. And both roads are what? 2 lanes. Both roads are 2 lanes and both are what? 2-way. Then we get 16 major conflict points and 8 minor conflict points. Yes. And total will be how much? Total will be 24. So normally people remember this 24 number. Okay. Normally what happens? People remember this 24 number. But in the examination they might ask you how many major are there, how many minor are there. They can ask you both. So you see a simple question was asked in GATE 2007, 1 mark question. This is IIT Kanpur question. So very easy question. So in a 2-lane road. So there are 2 roads. One is 2-lane national highway, 2-lane state highway. Doesn't matter. There are 2 roads only. Okay. And both are 2 lanes and 2-way. Right. And they're asking number of potential conflict points. So answer is what? C. Answer is C. But you see, the answer is C. What you see, they have asked in the IIT Kanpur, they have only asked the total number of conflict points. Okay. But if you just remember this and go, in the next time what they will ask? They will ask you find out what? The major ones and minor ones. Yes. So sometimes it's not only important to solve the previous year question, but also understand that they can ask you much more than previous years also. They can ask you much more than previous year. You should be ready. Like you see this question. They're asking you 2 major roads with 2 lanes each are crossing in an urban area. Okay, to form an uncontrolled intersection. Okay. The number of conflict points when both roads are 1-way is X. And when they are 2-way, it is Y. What is the value of X by Y? Many people might have remembered this answer, but I'll explain to you. You see what is written? That 1-way it is X. Now tell me this particular thing which we saw before. Here both roads were 2-way, right? When the both roads were 2-way, the number of conflict point is 24, right? Is 24. So I can say in this particular question, when it is 2-way, it is Y. So I can say Y is 24. Next thing is to find out X. Now see, we can just draw and find out. So we should know how to draw and find out also. You see here what happens. If we have 2 roads and both are 2 lanes, but 1-way. If they're 1-way, then can I say the traffic will be like this only, na? Right? 1-way only. Like this. And I can say the traffic will be like this. Only 1-way traffic. You can see that here we have 4 conflict points, right? Now you see this vehicle can turn left, so 1 more conflict point is there, right? Now tell me, can it turn right? No, na, it cannot turn right, na, because you see it is 1-way. It cannot turn right, so that right option is gone now. That right option is gone. And you see here only there can be 1 right. Because this vehicle cannot turn left, na. Why? Because it is 1-way. So you can see that in this case, the total number of conflict points is how much? It is only 6, right? The total number of conflict points is what? Only 6. When the 2 roads became 1-way, when the 2 roads became 1-way, 2 lane but 1-way, what happens? The conflict point is only 6. So X is how much? X is 6. So when both are 1-way, X is 6, conflict point is 6. When they are 2-way, the conflict point is 24. And they are asking what? Ratio of X to Y. So it is how much? 0.25. Okay. Now tell me, in this both roads 1-way, what is the number of major conflict points? You can see that the major conflict points out of this 6, the major is 4, na? The major is 4 and the minor is 2. The minor is 2. So they have not asked this question, but next time they can ask, right? So therefore it is, if you just remember previous year questions, now many students tell that, sir, we should solve previous question. That is very good. The thing is that if you solve only previous year questions and you don't understand the in-depth thing, then you will end up scoring 42, 50 marks in the GATE. Now tell me, 42, 50 marks in the GATE is not a failure. See, scoring 40 to 50 marks in the GATE is not a failure. But you will not end up in top IITs. You will not end up in, getting any good PSU. Not any good PSU, not getting any PSU. Okay. So, there is no use if you get only 40 to 50 marks. Okay. And by solving only previous year question, you will end up in this bracket of 40 to 50 only. Therefore, it is very important that along with solving the previous year question, you understand the background theory. So, these conflict points are there, and therefore we go for signal design. We'll have red light, yellow light, all right. So, in Webster signal design, what they ask you, okay, they will ask you, see, I cannot explain the whole Webster signal design here, okay. So, if you want to, how much rank required for PSU? Wow, good question. 80 plus. Get 80 plus marks. +80 plus marks. With below 80, everything is fishy. Okay. So Webster signal design. See, we cannot explain the whole signal design in 10 minutes. Okay. So in this, what they will ask you? They will ask you that the cycle length. The first thing they will ask you is what? Cycle length. The cycle length is equal to, the formula is C is equal to 1.5 L plus 5 by what? Your 1 minus y. Okay. Now, Webster signal design is, you see, this equation is very easy and you can solve questions also, no problem. Okay, no problem. But it's very limited time and I cannot cover all these things here. Okay. We cannot cover. So some other day we'll be taking this. I will take a full session on what? Webster signal design, how to find out cycle length, okay, then green time of each page, okay, what is a phase system and all many things I will teach in the some other session because that is not possible. In a 15 minutes, 20 minutes, half an hour I cannot teach the whole thing. So I'll take it in some other session, okay. So there are some questions, but they were not asked in Iit Kanpur. I just mentioned them. Okay, this is GATE 2016 question. This is also from what? Webster, right? Webster. And then you can see GATE 2007 is also from Webster, right? There's another question also, again Webster. So many questions they ask from what? From your Webster only. Okay, so many questions are asked from Webster. So I am thinking that if we take now, I cannot complete in a limited time and don't want to, hurry through. Many of the students know that I don't like hurrying through. I like to teach in details. Okay. So Webster method I will take in some other lecture. Okay, don't worry. I will conduct a session where I will teach you full Webster. Okay, don't worry. Okay. Now there is something known as what? There is something known as delay model. Okay. There is something known as delay model. Okay. Recently many questions are asked. 19 also asked and previous also have asked questions on delay model, okay, and there is something known as floating car method. There is something known as what? Floating car method. Okay, so I have taken 2 lectures on this. Okay, they are available on the YouTube channel. Our YouTube channel they are available. The traffic delay model. Okay, so it is a very important topic. Very important, I will say. The traffic delay model is a very important topic. Of late they are asking lot of questions they are asking from there, very important topic. So I'll request that you can visit, this is our YouTube channel, it's available on the YouTube channel only, traffic delay model, please cover this. I have completed this particular topic in great details, okay. And another very important topic is what? Floating car method, okay. I have covered this topic also, very important. So these 2 very important, I'll not say important, these 2 very important topics are there. So please cover them from our YouTube channel. I have covered them both. Okay. Some 1 hour, I have solved many questions on this. Okay. And I've given homework also in these particular topics. So you can cover them. Okay. So remaining one thing is what? Webster. I will teach Webster in a particular lecture. I'll take a 2-hour lecture and I'll complete Webster because Webster design, it's signal design. I don't think if we complete in half an hour, then it will make some sense, right? It will not make any sense, right? Okay, so thank you very much. So this was a previous year question session, okay, the small session, but actually we didn't solve only previous year question, right? Actually we learned many things. See, I taught you peak hour factor in details, right? Then I taught you the traffic model in detail. Then I taught you space headway and time headway and other things. 80 plus marks. You have to get 80 plus marks in GATE, 80 out of 100, so that we stand a good chance for a PSU. Okay, so we have to get 80 plus. 80 plus is the target. Okay, so please complete these 2 lectures, very important 2 lectures. And in this lecture, whatever I taught about your traffic stream models and and your peak hour factor, I have completed in details. So another day I will take a session on what? On Webster. I will take a 2-hour session and complete Webster also. Thank you very much. Tomorrow we'll have Highway Part 2, where we'll be discussing what? Pavement design and your geometry design. Obviously we cannot cover everything from pavement design, geometry design, obviously, but I will try to cover some of the very important topics. Okay, I will try to cover some of the very important topics, and as I told, I don't only solve previous year question, I will be teaching you the background theory also. Like today we learned peak hour factor. I didn't just solve the questions, I told the exact theory and what all things they can ask from that. Even if you see the linear model, the traffic stream model also, I told the background equations also, derivations also I did. I just not solve the previous year question. So tomorrow also we will be solving more question at 10:45. So please do come. Okay, thank you very much. 10:45 p.m. at the same channel. Thank you very much. Okay, thank you very much. Bye. Good night.